Today we're going to talk about equations of parallel lines and perpendicular lines. And we know these terms from before. We know that parallel lines are lines that never intersect, and we know that perpendicular lines are lines that form a right angle. So two lines are parallel if and only if their slopes are exactly the same. And that should make sense, and we'll look at that in a minute down below. Why parallel lines need to have the same slope. Now, perpendicular lines, the slopes of perpendicular lines are opposite reciprocals. And that's a complex term right there. So opposite means you change the sign. Meaning not only from positive to negative, but from negative to positive. And then reciprocal means you flip the fraction. Because we know slope as rise over run, as a fraction, and the reciprocal is when we flip the fraction. So let's look at these lines here and see if they're parallel, perpendicular, or neither. So I like counting from left to right. So I go up 1 and right 2. So the slope of this light blue line is 3 over 2. And then I go to line CD, I go up 3 and right 2 as well. So that slope is also 3 over 2. So these are parallel lines. And again, now that we can see a picture of it, it should make sense that to have parallel lines, the two lines have to have the same rise and run. If one of the lines had a different slope, they would eventually cross. Like in letter B right here. We can see that right now on this grid, the lines don't cross. But if you look down here, it says, well, eventually it looks like they will meet. But if the slopes were the same, for every time I went up, I would go over the same amount in both lines. So let's look at this one. We're going up 3 and right 3. So 3 over 3, which is 1. You could write that as 1 over 1, but just know that we usually simplify that to a whole number, if possible. And you go up 2 and right 3. So this line is 2 over 3. So those are obviously not the same. So we know that they are not parallel. And to see if they're perpendicular, look at if you flip this fraction, it becomes 3 over 2, and then change the sign to negative, it's not the same as 1. So this is neither. Now we look at these two. I'm going down 1 and right 2. So this slope right here is negative 1 over 2. Slope for BA, we're going up 4 and right 2. Now again, 2 can be written as 2 over 1. Now you can look at any of them first, either slope first. If we look at 2 over 1 and we flip it, that becomes 1 over 2. And then it says opposite reciprocal. So change it from positive to negative, and we get what we had up here. So that's perpendicular. That's sometimes the hardest one to see, is because people will forget to change the sign from negative to positive. So down here, we're going to do the same thing, determine if these lines are parallel, perpendicular, or neither. But instead of counting from the graph, we're going to use the slope formula. So remember the slope formula, and I'll write it once up here so that we have it to refer to for these problems. y2 minus y1 over x2 minus x1. So we're going to do it twice for each problem. So here's x1, y1, x2, y2 for line 1. And then for line 2, x1, y1, x2, y2. So each of these problems is going to have us do the slope formula twice. So L1 is for line 1. See, y2 is 4 minus y1 is 0 over x2 is 7 minus 1. That's 4 over 6. And that reduces to 2 over 3. You want to reduce your fractions at all time because that will allow us to easily see if the lines are parallel, perpendicular, or neither. So then line 2, right, y2 is 9 minus y1 is 0 over 3 minus 9. Okay, that is 9 over negative 6, which will simplify to 3 over negative 2. Now, this is where we want to see, are they the same? Obviously, they're not the same. One slope is negative, one slope is positive. And remember, when you have a slope, a negative slope, it doesn't matter if the top number is negative or the bottom number is negative. Just if one of them is negative, there is a negative slope. So if we were to take 2 over 3 and flip it, that'd be 3 over 2, but then change the sign from positive to negative, we have negative 3 over 2, which is the same as 3 over negative 2. So these two lines are perpendicular. So I want you to pause the video and try letters B and C right here. Calculate the slope for these lines, and then tell me if they're perpendicular, parallel, or neither. All right, so you can see my work for here. Letter B, the slopes are not the same, so it's neither. And in letter C, once you simplified the second line, you would see that they both have a slope of 1/3. So that means they are parallel. So down here, write an equation of the line that passes to the point negative 2 comma 3 that is parallel to the line with the equation y equals 3x minus 5. Now, we talked yesterday about point slope form, y minus y1 equals m times x minus x1, and that if you were given a point and a slope, that point slope form would be the easiest form to use. Now, the slope that we're trying to find, we went parallel to y equals 3x minus 5. So the slope of the given line is 3 because it's 3x. So that means the slope of the line we want to write the equation for must also be 3 because we want a line parallel to it. And the point that we're going to use is negative 2 comma 3. So now we can just plug these values in to our point slope equation, and that's all you have to do. So y minus 3, because that's y1, equals our slope 3, and it's x minus negative 2. So y minus 3 equals 3 times x plus 2. And that is our equation in point slope form, and that's as far as we have to go. So on this page, same thing, but we want perpendicular. The slope that we're already given is negative 2 over 3. So the perpendicular slope to that will be positive 3 over 2. We take 2 over 3, we flip it, and we change the sign from negative to positive. And then the point is going to be 1 comma 2. So again, we're going to do y minus y1, which is 2, equals m, our slope, 3 over 2, and then parentheses x minus x1, which is 1. and that would be our answer. That's what I'm saying. Point slope form makes life a lot easier than the process we did the other day with slope intercept. So what I want you guys to do is I want you to try these 4 problems here. Actually, I'll do example 5 and I'll have you guys try these down here. So let's look at example 5. We're going to use this point for both problems. So write an equation, a line that passes through this point and parallel to y equals 4x plus 9. Well, if it's parallel to 4x plus 9, that means we want our slope to be 4. So y minus 5, because that's y1, equals m, our slope, 4 times x minus negative 2 becomes plus 2. Then perpendicular to this line, your slope is going to be negative 1 over 4 because we flip over 4 over 1 and make it negative. So now my equation is going to be y minus 5 equals negative 1/4 times x plus 2. So you notice these 2 equations look exactly the same, except our slopes are different because we're going through the same point up here. All right, so I want you to try this part down here. And once you get the answer, unpause it to see if our answers match up. All right, so you can look at the answers here. Y plus 1 equals negative 2, and then in parentheses x minus 4, because we're going to the point 4 comma negative 1. And our slope has to be 2 because we want to be parallel to this line. And then for the other one, we want to be perpendicular, so we have to take that negative 2, flip it, and change the sign from negative to positive. Now example number 6, write an equation of a line passing through 2 comma negative 3 and parallel to y equals 4. Y equals 4 is a horizontal line. Now if we were just to draw a graph of this real quick, y equals 4 is right here, and it's a horizontal line. The reason why it's a horizontal line is because the y value is 4. Now if I want to be parallel to this, and let's just plot the point 2 comma negative 3, it's right here. If I want to be parallel to y equals 4, I think you guys can see that I'm going to have to draw the line horizontally as well. Well, since it's got to be horizontally, I want to take the y coordinate of the point, and that will be my line. Horizontal lines have the equation y equals a number. Now, perpendicular to the line y equals 4, well, perpendicular, again, forms a 90-degree angle. So again, if here's my point, and I want to be perpendicular to this line, my purple line, it's got to come straight down and be a vertical line. Well, a vertical line has an equation x equals a number. Well, it's going to be x equals 2. That's the x coordinate of that point. So it can be a little bit tricky with these values here, with these equations of parallel perpendicular lines that are parallel or perpendicular just to a horizontal or vertical line. That can get a little bit confusing, but with more practice, you'll get better at it. So I hope that this was a clear lesson for you guys. Remember, point slope form makes this a lot easier than converting it all to slope intercept. So thanks for watching. Make sure to like the video and subscribe.